Good morning, my dear students. So today in this sessions we are going to learn next problem in which we need to find out the nodal displacement vector and the nodal force vector, and we need to find out the stresses and strain at each element. We need to find out along with the normal reaction. We need to find out at the node 1, at the node 2 and the node 3. We need to find out. Okay, first of all I will read the question. Okay, a bar having uniform cross-sectional area. The area of this bar, how much is given here? 300 mm square is given, and it is subjected to a load of how much? 600 kilonewton load is acting. So where the load is acting? The load is acting at the middle portion of this bar. Is it right? So after that we need to determine the first thing is displacement. Displacement nothing but we need to find out the value of q1. We need to find out the value of q1 at the node 1, q2 at the node 2, q3 at the node 3, as well as we need to find out the stresses. So because we have how many node? 1, 2, 3 element. How many element we have? 2 element. The joining the first node to the second node, the forming of first element. The joining the second node to the third node, the forming of second element. Is it right? So for that reason we need to find out the 2 stresses at element 1, at element 2, as well as and support reaction in the bar. So support reaction here we have 3 node: first node, second node, third node. So for that reason we need to find out the normal reaction R1, R2, R3. Okay, so consider 2 element and use elimination method to handle boundary condition. Take modulus of elasticity or Young's modulus value is given as 200 gigapascal. Okay, in the solution, first of all we have to write down this given data. This given data is carrying for 1 marks. Okay, for the first element, okay, step by step we need to solve the problem. For element 1, so just now I told you the joining this first node to the second node, the forming of element, what we can say? E1. What we can say? E1. The joining the node from second node to the third node, the forming of element, this is second node. Okay, so first area, the area should be remaining same for all the element. Okay, the area A1 equal to how much? 300 mm again. So let us see. So I will write here. So this is first node. Okay, this is the first node, and this one is the second node, and this one is third node. The joining the first node to the second node, the forming of element, what we can say here? Element E1. The joining the node from second node to the third node, the forming of element, what we can say here? E2. This is E2. Okay dear, done. Okay, let us see. Because the area should be remaining same from first node to the third node, area A1 equal to how much? 300 mm square. Area A2 is how much also? 300 mm square for the element 1 as well as for element 2. Then the length of the first element, how much is given? This is, we can say as L1 equal to 150 mm. L2, the length of the second element is how much is given here? 150 mm is given. Okay dear, and then After that, here in this question, the modulus of elasticity or Young's modulus value is given. How much is given? 200 gigapascal. So we know very well 1 Pascal equal to 1 Newton per meter square. 1 Pascal is equal to 1 Newton per meter square. But if your intention is there, if you want to convert in millimeter square, so let us see, this is 200, giga means 10 power of 9, giga means 10 power of 9, okay. Then 1 Pascal is equal to 1 Newton per meter square. If you want to convert in milli means 1 Newton per 10 power of 3 whole square. Means it should be 10 power of 6. This 10 power of 6 and this 10 power of 9 will cancel. The remaining should be how much? 10 power of 3 Newton per m square. And how much load is acting at the middle of this bar? 600 kilonewton load is acting at the middle of the bar. If you want to convert in Newton, 600 as it is, kilo means 1000. 1000 we are representing in the form of 10 power of 3 Newton. Okay, I hope so no one is having doubt. Step number 1. The step number 1 is this finite element model for a given continuum. We are taking this body, okay, in a linear directions or a one dimension bar. We are representing this figure. Let us see, this is the first node. I am representing here first node, and this is the second node, and this one is the third node. Just now I told you the joining the first node to the second node, the forming of element, what we can say, element E1, we can say as element 1. The joining the node from the second node to the third node, the forming of element, what we can say, element 2. So at the node 1, the nodal force is acting, meanwhile the nodal displacement is acting. The nodal force and the nodal displacement is acting at a point of 1. It is represented by F1 and Q1. The nodal force F2 is acting at a point of 2, and the nodal displacement Q2 is acting at a point of 2. It is represented by Q2. And the nodal force F3 is acting at a point of 3, and the nodal displacement Q3 is acting at a point of 3. That's what I am representing here, F3 Q3, because the nodal force is acting at a point of 3. That's what I am representing the F3, and the nodal force is the nodal displacement is acting at a point of 3. That's what I am representing the point as Q3. Clear? After that, what we need to find out in the step number 2, in which we need to find out the elemental stiffness matrix. Here, how many elements we have? We have 2 elements, this first element and we have second element. So this means that we need to find out the value of K1, K2. If it is 3 will be there, then we need to find out 1, K1, K2, K3. Is it right? So this is the formula of elemental stiffness matrix. Ke is equal to Ae Ee by Le, 1 minus 1 minus 1 1. Okay, if you want to find out for element number 1, K1 is equal to area of element A1, the modulus of elasticity of material E1 by the length of the first element. It is represented by L1, 1 minus 1 minus 1 1. Area of the first element, how much is given? A1 is given as, let us see, 300 mm is given. How much dear? 300 mm is given. As well as Young's modulus or modulus of elasticity of the first element, how much is given? 2 into 10 power of 5. How much? 2 into, if you remove this 2 digits, it become as, it should be making as the power is 10 power of 2. If the bases are same, the power should be added. We can say as 2 into 10 power of 5, like this. 2 into 10 power of 5, I am represent direct. Otherwise you can represent as 200 into 10 power of 3. The meaning should be remaining same. Okay, the length of the first element, how much is given? 150 mm. How much? L1 is given as 150 mm. 1 minus 1 minus 1 1. If you divide the component, then you will get the value is 4 into 10 power of 5. 1 minus 1 minus 1 1. After that, you need to multiply 4 to the whole the bracket. 4 ones are 4, 4 ones are minus 4. 4 ones are minus 4 and this is 4. So this element 1, it lies in between the node of 1 and 2. This element 1, it lies in between the node 1 and 2. So that's what I am representing 1 and 2, 1 and 2 in vertical as well as in the horizontal. As well as we need to find out the element 2, we need to find out. What we need to find out? Elemental stiffness matrix we need to find out for the element second. The same concept, the same procedure we need to follow here. A2 E2 by L2, 1 minus 1 minus 1. So area of the second element, it should be remaining same. How much? 300. The modulus of elasticity of the material 2 is also remaining same, 2 into 10 power of 5. And the length of the second element is how much is given? Again 150 is given. Okay, Nadia? 150. 1 minus 1 minus 1 1. Again, if you divide the value, it will become as 4 into 10 power of 5. Same 1 minus 1 minus 1 1. So after that, this 4 we need to multiply to the bracket inside value. 4 ones are 4 and this is the minus 4 and 4. Always you need to remember one thing. So this element 2 is lies in between the which node here? Node second and node third. This element 2 is lies in between the node second and third. So that's what you have to represent the node second and third. In between this element is element second 2 is lies. Okay. Then after the getting the value of elemental stiffness matrix, okay, K1 and K2, after that you need to add the elemental stiffness matrix K1 plus K2. The K1 plus K2 we can say as global stiffness matrix. So global stiffness matrix is 10 power of 5. This K1 value is 4 minus 4 minus 4 4 1 2 1 2 plus 10 power of 5. This is 10 power of 5 4 minus 4 minus 4 and 4. This is the first node, second node, first node, second node, and this is the same as it is. We need to follow here. After that is the most important here only. So because generally you know very well, those are follow the lecture, he aware about each and everything, how to solve such type of the problem. Okay dear. Then so this node, first node, second node and third node, we have to arrange in a systematic manner, like first in the order manner, 1, after that 2, after that 3. Clear? Again the same thing we need to follow in the vertical position, first node, second node, third node. After that we need to multiply the first node to the first node. How much we are getting the value? First node to the first node we are getting the value is 4. We need to put here. And first node to the second node is how much we are getting? Minus 4. Here first node to third node is available here? No, not available. Here is available? Not available. If it is not available, first node to third node available, node is not available. For that reason it is considered as 0. Over. Again we need to multiply the second node to the first node is minus 4. Second node to the second node is how much? 4. Again here come to this toward right side. Second node to the second node, how much you are getting? Again plus 4. Okay. After that second node to the third node is available here? Not available. For that reason we need to eliminate this one. Go for this one. Second node to the third node is how much we are getting? Minus 4. Clear? And the third node to the first node is available here. Here also not available. Here also not available. If it is not available, it should be considered as 0. 3 to the minus. This is third node to the second node. How much we are getting the value? Minus 4. Third node to third node, how much we are to consider? Plus 4. Clear? I hope so. No one is having a doubt up to here. After that, okay, let us see. Okay, after that the global stiffness matrix I am representing here. K is equal to 10 power 5. 4 minus 4 0 minus 4, this is 8 minus 4 0 minus 4 and 4 I am representing here. This should be approximately equal to, we can represent the global stiffness matrix in this form. K is represent the global stiffness matrix. K, first node to the first node K11, first node to the second node K12, first node to the third node K13. Okay dear, come to the second node to the first node K21, second node to the second node K22, second node to the third node K23. Clear? Again, third node to the first node K31, third node to the second node K32, third node to the third node should be K33. K31, this is K31, this is K32, this is K33. Clear? After that, we got the value of global stiffness matrix. After that, what we need to find out, our main intention is we need to find out is displacement vector Q1, Q2, Q3 value, as well as we need to find out the nodal force vector we need to find out. Let us see the displacement vector we are representing here Q1, Q2, Q3, and the nodal force is here F1, F2, F3. But always remember one thing, in which one we have to consider. This is F1, nodal force F1 minus, we have to take this value K13, K23, K33, K13, K23, K33. So this is A3, not 1 3 here. Okay, A3, 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 A3. Clear? So what the A3 is represent? A3 is represent the maximum displacement at the node 3 it represent. Okay, so here generally if you observe this figure, how much gap is from 3 to this position? Let's see this figure. Third node to here, how much gap is there? So 0.12 mm. It is represent the A3. What they represent? A3, the nodal displacement. Clear? Okay dear. So the maximum displacement at the node 3 is how much? A3 is equal to 0.12 mm. So please make the correction here, A3. Clear? After that, the small changes due to gap between the node 3 and the fixed boundary condition. Here, which one is the fixed over here? The fixed one is node 1 is fixed, it become as 0, and node 3 also fixed, so it also become as 0. So for that reason, we need to eliminate the first row and the first column, and third row and third column we need to eliminate. How we need to eliminate? Let us see this up to here in the step number 5. Equilibrium equation for a given continuum. So here we have the equation. What is the formula? KQ equal to F. K value we have how much? 10 power 5, 4, minus 4, 0, minus 4, 8, minus 4, 0, minus 4 and 4 we have. And Q value is how much? Q1, Q2, Q3 we have. As well as here the nodal force is F1 minus K13 A3, F2 K23 A3, F3 K33 A3. Clear? So in this equation, because the node 1, this node 1 is fixed, so for that reason we need to eliminate this first row, first column. Okay, I hope so no one is having a dot up to here. And node 3, okay, node 3 is having the maximum displacement. How much displacement is given here? 0.12 mm. So for that reason, what I am doing here, I am eliminating this value. Okay, so we are eliminating the first row, first column, as well as third row, third column. Okay, so after that we are getting how much value? Only 8 Q2, and this value we are getting F2 minus K23 A3. Okay dear, after that we need to apply the boundary condition. In the boundary condition, we know very well we have to go for which method? Elimination approach method we have to go for it. 10 power 5 as it is, we need to multiply 8 into Q2 equal to F2 minus K23 A3. So this problem is a little bit different here. Okay, after that 8, if you multiply 8 into 10 power 5, Q2 equal to the force F2, how much is there? We know very well, because this force F2 is acting where? At the middle point. where at the middle point. How much F value is given? 600 into 10 power of 3 Newton value is given. Is it right? Minus K23. K23 is how much we got it here? Minus 4 into 10 power of 5. So you are thinking that, sir, how you got this K23 value? Let us see. Just now I told you this K23 is minus 4. K23 is minus 4 into 10 power of 5. We can represent here minus 4 into 10 power of 5. This A3 nothing but the gap. Okay, so gap will be there. How much gap will be there in the component? 0.12 mm. We know very well how much? 0.12 mm. The same thing I am representing here, 0.12. After that, 8 into 10 power of 5 Q2 equal to 600 into 10 power of 3. Minus into minus, it should be become as plus. This should be 4 into 10 power of 5 into 0.12. If you multiply, then you will get the value is 48 into 10 power of 3. So if you are adding this whole the value, again you need to divide here. Then you will get the answer is Q2 is equal to 0.81 mm. So in this one we understood that the Q1 value is 0 because of it is a fixed and Q3 also it is a fixed and Q3 also 0, and we got the value of Q2 is how much? 0.81. After the getting the value of Q1, Q2, Q3, again we have to go for the stress as well as strain for the first element as well as for the second element we need to find out. Then how to find out? Let us see. In the step number 7, in which we need to find out the stresses as well as strain we need to find out. First we are going to find out the strain for the first element, E1 equal to B1 into Q. Okay, B1 value we know very well, 1 by L1 minus 1 Q1 Q2. 1 by length, the length of the first element how much is given? 150 minus 1 and the Q, the displacement Q1 is fixed, and so that's what is considered as 0. Q2 already we have find the value how much? 0.81. After that 1 by 150 as it is. So you need to multiply this horizontal vertical, okay, row to this column. Minus 1 into 0, 0 plus 1 into 0.81, it become as 0.81. If you divide the value of 0.81 by 150, then you will get the value of strain is 5.4 into 10 power of minus 3. After the getting the value of strain, we need to find out the stress value. Stress value is stress equal to modulus of elasticity into this value, what we can say? Strain. B1Q, what we can say? B1Q, what we can say? Strain. So what is the value we got it here? 5.4 into 10 power of 3. Wherever the E will be there, you need to substitute this value, 5.4 into 10 power of minus 3. So the modulus of elasticity or Young's modulus value is given as 200 into 10 power of 3. Just you need to multiply this term, then you will get the answer of stress is 1080 Newton per mm square. So the unit of this stress is Newton per mm square. Okay. After that, what we need to find out? We need to find out the strain for the second element. We need to find out. The same procedure we need to follow here. Strain E2 is equal to B matrix into nodal displacement. The B2 we are representing here 1 by L2 minus 1 Q2 and Q3. So 1 by length L2 how much we got it? 150 minus 1 and this Q2 value is 0.81 and the Q3 is how much we got here? 0.12. So Q3 always you need to remember one thing, because we are considering the Q3 value. Q1 is 0, Q2 is how much? 0.81. Q3 is the gap between from third node to the fixed end. How much? 0.12. We have to take as Q3 is 0.12. 150 as it is. Just you need to multiply minus 1 into 0.81 plus 1 into 0.12. Okay. After that, if you divide the value, then you will get the answer of the strain is minus 4.66 into 10 power of minus 3. Because we know very well the strain is not having any unit, it is a dimensionless unit. Okay dear. and then again we are going to find out the stress. We have the same formula we need to follow here. Stress sigma 2 is equal to E2 into B2 into Q. E2 is the modulus of elasticity or Young's modulus values. How much is given here? 200 into 10 power 3, and this strain, okay. So because I did here directly, because you need to find out the first okay, B2 into Q, how much? The value is minus 4.66 into 10 power 3. Okay dear, just you need to multiply this term, then you will get the answer of minus 920 Newton per mm square. The same procedure, whatever we did, not same concept we need to follow for to find out the stress for the first element as well as to find out the stress for the second element. We need to follow the same concept up to the last end. Okay, there is no changes in the stress as well as strain. After getting the stresses and strain, we need to find out the reaction at the support. We need to find out. So we know the formula R is equal to KQ minus of F. So R nothing but the normal reaction is acting at a point of 1, it is represented by R1. The normal reaction is acting at a point of 2, it is represent the R2. The normal reaction is acting at a point of 3, it is represent the R3, equal to this K nothing but the global stiffness matrix, it is represented by 10 power 5 4 minus 4 0 4 8 minus 4 0 minus 4 4. And this nodal displacement, that is the value of Q1, Q2, Q3. Q1 is a fixed, and for that reason it is considered as a 0, and the Q2 already we find how much, 0.81, and the Q3 nothing but we have the gap between from the third node to the fixed end, from third node to the fixed end. So that's what, how much gap is given here? Is given as 0.12. For that reason I consider the value of Q3 is 0.12. Okay, after that we need to find out the nodal force, F1, F2, F3. So nodal force, the force at the point 1 should become as 0, the force at the point of 3 it become as 0, as well as the force at the middle point is 600 into 10 power 3. Okay dear, after that the same concept we need to follow here. R1, R2, R3 equal to 10 power 5. We need to multiply this row into this column, first row into this first column, second row into this first column, third row into this first column. Okay, then how we are multiplying, let us see over here on this screen. 4 into 0, it become as 0, minus 4 into 0.81 plus 0 into 0.12 minus 600 into 10 power 3 0. Again the same concept we need to follow for the middle portion. 4 into first point, 4 into 0, 8 into second point, 8 into 0.81, this minus 4 into 0.12. Again this third row into this first column, 0 into 0 should be become as 0, minus 4 into 0.81, okay, plus 4 into 0.12 minus 600 into 10 power 3 0. After that, if you add this value, then you will get the answer is minus 3.24. If you add this value, then you will get the value of 6.48. If you add this value, then you will get the value of minus 2.76 minus 600 into 10 power 3 0. Okay here, after that what we have to do, let us see. This is normal reaction R1, R2, R3. You can follow this method as well as early method, you can follow this your wish. The same concept will be there. 10 power 5 as it is, minus 3.24 into 0, minus 3.24 minus of 0, 10 power 5 into 6.48 minus 600 into the power 3, 10 power 5 into minus 2.76 minus of 0. So if you multiply this term, then you will get the value is minus 324 into 10 power 3. So if you add this value, then it will become as 0. If you multiply this term, it will become as minus 276 into 10 power 3. So after getting the value of which one? First one is stresses sigma 1 E1, sigma 2 E2, okay, as well as the nodal displacement value q1 is 0, q2 is how much, 0.81, q3 is 0.12 mm. So in the result, that is the most important for the external examiner, because if you are not represent this result, maybe they have the possibility to cut your marks. Based on that, he will give the full marks. Okay, don't forget to represent on the external examination point of view, I am telling you. Okay, first of all, the nodal displacement value, it is given as q1 is a fixed end, that's what is considered as 0, and the nodal displacement q2 is how much, we got it here, 0.81, and q3 the nodal displacement, because the gap between the third node to the fixed end, this is third node and this is a fixed end, how much is there, 0.12 mm. Okay, after that we need to find out the stresses. The stresses for the first element is, we got it strain for the first element we got as 5.4 into 10 power of 3, as well as the stress for the first element is 1080 Newton per mm square. The strain for the second element is minus 4.6 into 10 power of minus 3, and the stress for the second element is minus 920 Newton per mm square. After that, we have found out the normal reaction at this support is how much normal reaction is acting at a point of 1, minus 324 into 10 power of 3 Newton. The normal reaction is acting at a point of 1, and the normal reaction is acting at a point of R2, it become as 0 Newton. The normal reaction is acting at a point of 3, R3, it is should be equal to the minus 276 into 10 power of 3 Newton. Okay, I hope so. No one is having the doubt regarding up to here. If you have the small doubt also, you can write down in the comment box. Please guys, okay, please like, subscribe my channel. Okay, thank you. In the next problems, we are going to discuss the 10th problem, that is the most important for the external examination point of view. Okay, thank you.